In 13.3, we're going to graph some functions. So, an example. A local store buys old computers. The store reuses the parts it can, and it sells refurbished computers from those parts, and they make $200 on each computer they sell. Make a table showing how much money is made for selling computers. Then plot those points on a graph. Okay, so what this is going to be is number of computers and money. So if they sell one computer, they make $200. Two computers would be $400. At $200 for each, we're just going to be taking the number of computers times 200. 3 computers gets us $600. 4 computers would make us $800. And 5 computers would make us $1,000. These are enough points. Guess I don't really need to include the dollar sign there. Now, this is a table of values. The left column are X numbers and the right column are Y numbers. And secretly, these are all ordered pairs. If I just fill in some parentheses and some commas, these are the ordered pairs 1, 200, 2, 400, 3, 600, 4, 800, and 5, 1000. We have to plot these points. We have here a coordinate plane that is just the first quadrant, which is all I need because all of the numbers are positive. What it doesn't have on it are units to count by. On the x-axis, that's not really a problem. The x values are the numbers of computers, and those are just 1, 2, 3, 4, and 5. So if we were to put a label down here and say this is the number of computers, and we put the bottom corner as 0, I'm even going to space these out a little bit. I'm not going to count each line as being 1, I'm going to count every other line as being 1. So I'm going to say the second line is 1, the fourth line is 2, and again, I'm just skipping 1 each time so I can space these out just a little bit. The problem really comes in counting up the y-axis for money, because I've got 200, 400, 600, 800, and 1000. I cannot possibly count by 1 and fit that on this graph. I couldn't even fit 1, 200 on this graph, the first point, if I counted by ones. Instead, I probably need to count by 100ths. Now, in the interest of space, I'm not going to label every single line. I'm not going to, I will show you real fast. I'm not going to label this 100, 200, 300, and you can see why. These numbers are very small and very cramped already. That's not good. We can count and label every other line. So the first line is going to be 100, but I'm not going to write it. Instead, I will label the second line as 200 in a number large enough to read. The third line is 300, but we're not going to write it. The fourth will be 400. 500, 600 gets written. 700, 800 gets written. 900 and 1000 gets written. And we should include a label somewhere here of dollars. Now we can plot our points. 1, 200. So I go to 1 and where 200 intersect, which is there. 2 and 400 intersect there. 3 and 600 intersect there. 4 and 800 will intersect there. And 5 and 1000 intersect there. This is just showing that sometimes we have to count by numbers other than 1. And that's okay. We don't want to count by giant numbers, like I wouldn't count here by 1000s for the amount. You want to count by something small enough that makes sense. If you can count by 100 and fit everything comfortably, do that. If you can count by 2 instead and fit everything comfortably, do that. You want to count by the smallest number possible that still makes sense. Okay, counting by anything bigger than 100 here would put these dots so close together we wouldn't really be able to tell much of a difference. Example, graph the data, then write an equation that relates x and y, and then find the missing value of y. So this is taking what we're doing right now, graph the data, what we did last chapter in chapter 12, write an equation relating x and y and find the missing value of y. This is just combining chapter 13, lesson 2, with chapter 12, lesson 2. So graphing the data. -5, -3, remember, an xy table gives us ordered pairs. So -5, -3 says left 5, down 3. So 1, 2, 3, 4, 5 left, and then down 3, roughly there. -3.5, -1.5 says go left 1, 2, 3, and a half spaces. So we're kind of on this line here. And down 1.5 spaces, which is kind of, that's a little low actually. Which is kind of, that's still ridiculously low. Come on, be nice, iPad. Which is basically there. The 0.5 means halfway in between. So this ordered pair is actually going to be in the middle of a block. It's meh. I can do a little better than that, I think. Roughly there. This is one of the things I'm not a fan of with your book. I don't like the fact that it includes the half spaces. But it does, and we'll deal with it because we can. -2, 0 says go left 2 and don't go up or down at all. So it's there. 0, 2 says don't go left or right at all, but do go up 2. So it's there. And 1.5, 3.5 is another one of those goofy ones. So 1.5 says go right 1.5 spaces. That is not 1.5 spaces. Which is roughly there. It's right between 1 and 2. And go up 3.5, which is 1, 2, 3, roughly on this line, halfway between 3 and 4. So this is another one that's going to be sandwiched between the lines in the middle of a block. So we have graphed the data. You only have to graph the complete ordered pairs. You do not have to go back and graph this once we figure out what's missing. Okay, that's free. You don't got to graph it. Write an equation relating x and y. So we did this last chapter. We said y equals and then something with x. The question is, how are these x values becoming the y values? Well, I'm going to pick something with easy numbers to work with, which means I don't want decimals if I can avoid them. I don't want negative numbers if I can avoid them. And I only have one block here that gives me that possibility, 0, 2. So the question is, how does 0 become 2? And there's only one way 0 can become 2. It's by the addition of 2. The question is, does that work everywhere? Is -5 plus 2 -3? Yes. Is -3.5 plus 2 -1.5? Yes. -2 plus 2 is 0, and 1.5 plus 2 is 3.5. So the rule here is that we're adding 2. That is our equation. Find the missing value of y. Well, okay, that means we need to add 2 to 2.5. So the missing value is 4.5. And that's all you need to say. Remember, you don't have to go back and graph that. And that's actually the end of the notes for 13.3.